Hello. We're just going to do a few more complicated acceleration problems. I'm going to show you one problem where the math gets kind of a little tricky, and there's a maybe a longer but easier way to do it, and then a couple of problems where I call what I call segmented problems, where there's like acceleration changes during the problem. So let's get to it. So the first one here is a problem where I want to show you a different math way to solve it. When the more obvious math way, it becomes a little bit tricky for some people. Okay, so we've got a car traveling at 5 meters per second, and accelerating at 2 meters per second squared until it travels 100 meters. And I want to know how long does it accelerate. So how long? What time period are we talking about here? So as with all these problems, right, the first step is to identify what variables we know. So we've got traveling at 5 meters per second squared. That's at the starting. So we've got v initial equals 5 meters per second. We've got an acceleration of 2 meters per second squared. And we've got a displacement, a change in x, of 100 meters. Okay. So, three variables. And I want to know how long. So I'm looking for time. Now, the good news, or what you would hopefully immediately see, is that this is four variables that all exist in the same equation. It's the change in x equals v initial times time plus 1/2 at squared. So let's solve it that way. That seems like the easiest way to do it. Let's get to it. Oops. I'm gonna knock some stuff over here, guys. Alright, so I've got a change in x, 100 equals 5 times t plus 1/2 times 2 times t squared. 100 equals 5t plus t squared. So that becomes t squared plus 5t minus 100 equals 0. And now we can use the quadratic formula or use a quadratic solver or some sort of thing like that. You can't factor this one. Otherwise I would try. I definitely don't mind factoring, but I don't like the quadratic formula. I could plug it into Google, but if I'm on a test, I can't do that. So what if there was another way? Oh, by the way, the answers you get for this are 7.8 or 12.8 seconds. And the answer you want is the first one of those two. But what if I don't want to do those two? Is there another way? So what if I found v final, right? So this is my alternate solution here. What if I found v final first? So what if I use the equation v final squared equals v initial squared plus 2a change in x? Well, I've got v final squared is unknown. I've got 5 squared plus 2 times 2 times 100. So v final equals the square root of 425, or 20.6 meters per second. Now that's not the answer. That's not what I'm trying to find. But the second step of this is that I can then look for time using the v final equals v initial plus at. So this becomes 20.6 equals 5 plus 2 times t, right? 15.6 equals 2t, and I get that t is equal to 7.8. So it doesn't matter to me which way you do this problem. The point of this problem is simply that if you're someone who's uncomfortable with the quadratic formula, and it only happens with this equation. This is the only equation when solving for t where you get a quadratic formula with the kinematics equations. So it's the only time you'd have to do it. But if you're uncomfortable with the quadratic formula, this might not be the way to do it, and maybe you do it with two equations instead of one. Again, it only happens when you're trying to solve for t using that equation. So sometimes then you might have to go for two of them. All right? Okay, moving on to the bigger sort of concept for today. What if we have a problem where the acceleration is two different things? So right here we have a car. It's initially at rest. It accelerates at 3 meters per second squared for 8 seconds. It then decelerates to a stop at 2 meters per second squared. Now I want to know how far it's traveling during its deceleration, so just that second part. So, right, I just gotta look at the second part, right? So we got the first part over here, right, that I can ignore. But let's, first part, and here over here we got the second part. This is the deceleration. All right, well, I've got a deceleration. A is, say, it's in this case, it's -2, right? It's deceleration. I know it doesn't always mean negative, but everything else is positive, so let's say its velocity is positive. It's decelerating to a stop, right? To a stop, that means that v final is 0. And I want to find change in x. But here's the problem. I only have 2 variables, and we know we need 3. Always need 3. So where's my third variable? I don't have it. So let's go back to that first part. Okay, I mean, I know it's not actually what we're trying to solve for, but what information do I have here? Well, initially at rest, right? Initially at rest, that's v initial equals 0. We got an acceleration is 3, and a time is 8. Well, I can solve for something from that, but what do I want to solve for? Right? Do any of these help? Like, does anything over here help me over here? Turns out the answer is yes. If I solve for v final, okay, v final equals v initial plus at, I should get that this is 24. Now, this is the velocity at the end of the first segment. The end of the first segment means 8 seconds after the acceleration starts. It's also the very beginning of the second part. So this 24 meters per second becomes the v initial here. Okay? And all of a sudden, I can solve this. I have a third variable here. Okay? So the point here is that when you have these segments, when you have different accelerations, the thing that links between them is that the velocity at the end of the first part becomes the velocity at the beginning of the next part. Okay? So now I've got this, and I want to find change in x. Well, I can use v final squared equals v initial squared plus 2a change in x. This is 0, 24 squared plus 2 times -2 times x. 24 squared is a big number. 500 and I didn't write this intermediate steps down. That's okay. I'm going to do it. It's 576. 576. Actually, let me erase that because I'm putting it on the wrong side here. This is 576, right, minus 4x, 0. 4x equals 576. X is 144. So the answer is 144 meters for the second part. But again, the main point here is this final velocity of this first part is the initial velocity of the second part. Okay. This next problem here is pretty similar to that previous problem. Again, we have different accelerations. But this part's going in 3 parts. We've got an elevator. It needs to travel up 10 floors, which is about 35 meters. That's a little over 10 feet per floor, which is about right. The elevator's max acceleration or deceleration is 2 meters per second squared, and its maximum velocity is 5 meters per second squared. Okay? So what happens? There's actually 3 stages here. Stage 1, accelerate. Okay. Stage 2, where it's at max speed. And stage 3, decel. Okay? And let's go through what we know about each of them. We know that the velocity initial is 5, and the velocity final is 5, right? It's at max speed that whole time. And the acceleration, therefore, is 0 because there's no change. In stage 1, the initial velocity is 0. How do we know that? Well, elevator start at velocity of 0. You're not jumping onto a moving elevator. I don't care how many movies you watch where they do that. That's not us. Okay. V final is 5 because that's the maximum speed. So it's going to keep accelerating until it reaches there. And the acceleration is 2. Okay. Here, right, because the final velocity of the second stage was 5, V initial is 5. Okay. V final is 0 because it's slowing down, and A is -2. Okay, so you might think I've got 3 values for each of these, so I can always find time. So I'm going here, time is V final equals V initial plus AT, right? So this is 5 equals 0 plus 2t, t equals 2.5. I can do the same thing here. V final was V initial plus AT. This is 0 equals 5 minus 2t. T is also 2.5. Perfect. Now I just need to do the middle part. Oh, same equation, right? I'm still trying to find that t, so V final was V initial plus AT. Well, we've got 5 equals 5 plus 0t. Uh-oh. So if your acceleration is 0, you actually can't use this equation to find t, because t is multiplied by 0. It could be anything. How else can we get it? Well, we know the total distance is 35. So what if I found out how far it goes in stage 1 and stage 3, and then bring those together into stage 2? That sounds perfect. So I can do a bunch of different ways here. I'm going to do change in x equals V initial times time plus 1/2 AT squared. This is x equals 0 plus 1t squared. T is 2.5. I guess I could put that in there, but really this comes out to be 6.25 meters. Do the same thing here. Same equations, and guess what? You end up with x equals 6.25 as well. 6.25 plus 6.25 is 12.5, which means this becomes, the change in x here is 35 minus 6.25 minus 6.25, and this becomes 22.5 meters. And now, right, we can find the time, because change in x still equals V initial times t plus 1/2 AT squared. This whole bit is 0, so 22.5 equals 5t. T equals 4.5 seconds. So my final answer is 2.5 plus 2.5 plus 4.5. So equals 9.5 seconds. Feels a bit fast for an elevator going up 10 floors, but we'll pretend it's one of those express elevators. All right, hope that helps. These ones you break into parts with the acceleration is kind of the key focus here. Really pay attention to that. If the acceleration is not the same at all times, you've got to do that. All right, have a good one.